Dear students, in this lecture we will learn the classical Runge-Kutta method, or the second name of classical Runge-Kutta method is fourth order Runge-Kutta method, abbreviated as RK4. So fourth order RK method is important to learn. The third order, second order methods are not very much important. Most of the questions in the paper are included regarding classical Runge-Kutta method. So let me explain the steps for RK4 method. The first one is a differential equation will be given to you people as discussed before. Initial approximation will be given to you as discussed before in Euler technique. Step size h will be given to you people, and the very much important thing is you need to learn the classical RK method, or secondly RK4 method. This is the formula for RK4 method. Yn plus 1 is equal to yn plus 1 by 6 times k1 plus 2k2 plus 2k3 plus k4. We know about if you replace n, if you replace n by 0 here and this formula, so you will get y1 is equal to y0, and y0 is given to you, will be given to you in the question, and plus 1 by 6 times k1, k2, k3 and k4. We need the values of k1, k2, k3 and k4 for this formula. So how could you find the values of these k's? K1 is actually h times function of x and yn, and k2 is h times function of xn plus h by 2 comma yn plus k1 by 2. Just add h by 2 with xn and k1 by 2 with yn, so that is your k2. K3 is the same. If you see here, xn plus h by 2, but you need to add k2 by 2 with yn. For k2 you need to add k1 by 2, and for k3 you need to add k2 by 2 with yn, so that is k3. And k4 will be obtained by adding h with xn and k3, the previous k3, with yn. So that is the whole process to find the values of these k's, and put all these values in this formula, you'll get yn plus 1. Now whenever you put n is equal to 0, you will get the first approximation. Whenever you put n is equal to 0 here, so you'll get y1, and whenever n is equal to 0 here, so that is x0 y0, that will become x0 plus h by 2, y0 plus k1 by 2, and that will become x0 plus h by 2, y0 plus k2 by 2, and that is x0 plus h and y0 plus k3. So put all those values right here to get y1, and whenever you put n is equal to 1, you'll get here y2 is equal to y1. Y1 will be obtained in the previous session, and whenever you put n equals to 1 here, so that will become x1 y1, and all those xn's and yns will be replaced by 1, so you will get y2. And whenever you need to find y3, so you need to replace n by 2, you'll get y3 here, and all those xn's and yns will be replaced by y2. So that is the methodology for RK4 method. Let me explain one example in front of you people to understand the idea of RK4. The question is solve ODE y prime is equal to y minus 1 by y plus 1 subject to the conditions y0 is equal to 1 by using classical RK method over the range this thing x lies between 0 and 0.5 with h is equal to 0.1. That is the same range which was given in the Euler's method, that x starts from 0 up to 0.5 by taking this step. And so if this is the values for x, so x naught will be 0, x1 will be adding 0.1 with this 0, so that will be 0.1, x2 will be 0.2, x3 will be 0.3, x4 will be 0.4, and x5 will be the last value, which is 0.5. Anyways, we need to use RK method to solve this differential equation. The given data is y prime, which is usually denoted by a function of x comma y, is given to you y minus x divided by y plus x. So this implies whenever you replace x by xn and y by yn, so that will become yn minus xn, yn plus xn. That is function of xn yn. Also this initial condition y of 0 is equal to 1, that is given to you people. So from here we see that x naught is 0 and y naught is 1. So x naught is 0 and y naught is 1, and h is already given to you, which is 0.1. So this data is given to you. For first approximation y1, for y1 keep concentrating from here, because we are going to find y1, and in the same manner you can find y2, y3, y4, and so and so. So how could we find y1? We need to put n is equal to 0 and those formulas for k's and yn plus 1. So k1, we know that k1 is equal to h times function of x and yn. So whenever n is equal to 0 here, so that will become h times function of x naught y naught. So function of x naught y naught will be obtained here from there. X naught y naught will be y naught minus x naught divided by y naught plus x naught. So that is y naught minus x naught divided by y naught plus x naught. This is the value of function of x naught comma y naught, and h is replaced by 0.1. Now putting the values of y naught and x naught and this fraction, this is x naught and this is y naught. So replacing these values, you'll get k1 is equal to 0.1. Now we know that k2 is h times function of xn plus h by 2 comma yn plus k1 by 2. This is k2, but we need to put n is equal to 0 in this formula. So whenever n is equal to 0, so that will become x naught plus h by 2. So that is x naught plus h by 2, and this is y naught plus k1 by 2. But x naught is given to you 0, h is given to you 0.1, k1 is this thing 0.1, which you have obtained in the previous step. k1 is equal to 0.1. So k1 is 0.1. So we have replaced all those values to get 0.1 times function of 0.1 by 2 is 0.05 by calculating, and 1 plus 0.1 by 2 is 1.05 after calculating. So that is the function of 0.05 comma 1.05. It means that instead of xn we need to put 0.05, and instead of yn we need to put 1.05. So in this formula, instead of yn we need to replace 1.05, then minus xn. So instead of xn, this is 0.05 divided by yn plus xn. So that is yn plus xn, and this is h. So that is the function of 0.05 comma 1.05. Calculating this fraction, we'll get 1 by 1.10, and then dividing 0.1 by this number, we'll get 0.0909. That is the value for k2. Now k3 is and the formula is h times function of xn plus h by 2 comma yn plus k2 by 2. But we need to put n by 0 for first approximation. So x naught, that will become x naught plus h by 2, y naught plus k2 by 2. So x naught plus h is 0 0.1 by 2, h is 0.1 divided by 2, and y naught plus k2 by 2, but k2 is obtained here, which is 0.0909. So that is 0.0909 divided by 2, that is this thing. But x naught is 0 and 0.1 by 2 is 0.05, and y naught is 1 plus divided by 2, we'll get 0.0455. Now this will become h times function of 0 plus 0.5 is 0.05, and 1 plus this thing is 1.4, 1.04. 0 is missing here, 0 is missing here. We see that this is 0, so put 0 here, that is 0. So that is function of 0.05 comma 1.0455. So that is if you look around here, instead of xn here is 0.05, and instead of yn here is 1.0, put 0 here, okay, 1.0455. So replacing in this fraction, we'll get second minus first, that is second minus first divided by second plus first. So from here, that is second minus first divided by second plus first, and calculating this fraction, we'll get this answer. Try to correct this number, that is 1.0455. Correct this number. Maybe this answer is wrong regarding this 0 number, so correct this number. Anyways, calculate k4. How could we calculate k4? This is the formula for k4: h times function of xn plus h comma yn plus k3. So that is we are going to put n is equal to 0. So that will become function of x naught plus h, and that is y naught plus k3. But x naught is given to you 0, and h is given to you 0.1, y naught is given to you 1, and k3 is obtained here, which is 0.0934. So that is 0.0934, and the next step, that is h into function of 0 plus 0.1 is 0.1, 1 plus 0.0934 is 1.0934. So putting this these values in the function, that is the function, and in the function, function is this one, second minus first divided by second plus first. So from here, this is h is 0.1, and function of this thing is second minus first, second minus first divided by second plus first. Calculating this fraction, we'll get 0.0183. That is k4. So therefore yn plus 1 is this thing, and whenever n is equal to 0, we'll get this side y1, that will become y naught plus 1 by 6, that is 1 by 6, k1 is obtained from here, that is 0.1, so that is k1 plus 2 times 2 is common in these two, so we have taken 2 common, then k2, this is k2 which is obtained here, that is k2 plus k3, that is k3 plus k4. This is k4 from here. This is k4. Calculating this sum, we will get y1 is equal to 0.0812. So y1 is equal to 0.0812. That is for the first approximation y1, we have replaced n by 0. If you want to find second approximation y2, so we need to put n is equal to 1. We need to put n is equal to 1 in all those formulas. Whenever n is equal to 1, that will become x1 y1, and x1 y1, this formula will become y1 minus x1 divided by y1 plus x1. y1 is obtained here, 0.0812, that is y1, and x1 is given to you, which is 0.1. So that will become y1 minus x1 divided by y1 plus x1, and calculating you will get k1. The same thing, that will become x1 plus h by 2, that will become y1 plus k1 by 2, and so on. So in the same manner, you can find those approximations by putting n is equal to 1, 2, 3, 4 in all these cases, and finally n plus 1 to get y2, y3, y4 and y5. If you look at here, we have replaced we have written the values of n up to 5, the values of x, x0, x1, x2, x3, x4, x5, and this is y1, y2, y3, y4, y5, y6. These are the values for k's, k2, k3, k4, and the last value is yn plus 1. We have calculated y1 0.0812, and then y2, y3, y4 and y5. This is the value of y5, which is the final value of this approximation. So this is how we use RK4 method to find the solution of the given differential equation, first order differential equation. The second lecture, the second topic will be how could we use calculator to find these values quickly with the help of a calculator. So that will be the upcoming lecture. I hope this lecture will be helpful for you people.